Hello everyone, my name is Cecilia and I'm from class 10 and today I'll be discussing about hydrocarbon. So, hydrocarbon is an organic chemical compound composed exclusively of hydrogen and carbon atoms. Hydrocarbon can form the basis of crude oil, natural gas, coal, and other important energy sources. Hydrocarbon divided into two. The first is saturated hydrocarbon, and the second is unsaturated hydrocarbon. First, I'll be explaining about saturated hydrocarbon. Saturated hydrocarbon is a hydrocarbon that has single bonds between carbon, such as alkane and cycloalkane. The general formula of alkane is CnH2n plus 2, where n is equal to 1, 2, 3, or etc. Alkanes, known as saturated hydrocarbon, because they only contain single covalent bonds and contain the maximum number of hydrogen atoms that can bond with the number of carbon atoms in molecule. The example of alkane are methane, ethane, and propane. Guidelines for naming the alkane. The first is, choose the longest chain, this will be the parent. Number the carbon atoms from a terminal carbon where a branch is closest. Name the branch using a prefix based on the number of carbon atoms, then add the suffix YL. Name the parent according to the number of carbon atoms plus the suffix ANE. Acknowledge the carbon position of the branch, then name the compounds starting from the branch and followed by the parent. Arrange the branches in alphabetical order except for the prefixes D, tri, tetra, or etc. For multiple same branches, use the prefix corresponding to frequency. The general formula of cycloalkane is CnH2n, where n is equal to 3, 4, 5, or etc. Cycloalkane are alkanes whose carbon atoms are joined in rings. The example of cycloalkane are cyclopropane and cyclobutane. Next, I'll be explaining about unsaturated hydrocarbon. Unsaturated hydrocarbon is hydrocarbon that have double or triple covalent bond between carbon atoms, such as alkene, alkyne, and aromatic. The general formula of alkanes is CnH2n, where n is equal to 2, 3, 4, 5, or etc. Alkanes have at least one double bond of carbon atoms. The example of alkanes are ethene and propene. The general formula of alkynes is CnH2n minus 2, where n is equal to 2, 3, 4, or etc. Alkynes contain at least one triple carbon bond, and the example of alkynes are ethyne, propyne, and butyne. Aromatic hydrocarbon or benzene are aromatic organic compounds containing solely carbon and hydrogen atom. The aromatic hydrocarbon known as phenyl group. The example of aromatic hydrocarbon are ethylbenzene, styrene, toluene, and aniline. Unsaturated hydrocarbon have more reactive and high boiling point and high melting point compared to saturated hydrocarbon. This happens because unsaturated hydrocarbons are not stable enough compared to saturated hydrocarbon due to their bonding. Unsaturated hydrocarbon contains of alkene, alkyne, and aromatic hydrocarbon. The most reactive among them is alkyne, due to the triple carbon bond, which it has more free bond, which makes it reactive. The second reactive in unsaturated hydrocarbon is alkene. Lastly, the least reactive in unsaturated hydrocarbon is aromatic hydrocarbon or benzene, due to the delocalized base system. Saturated hydrocarbon contains of alkane and cycloalkane. Alkane and cycloalkane has very similar in reactivity, except for cyclopropane. Cyclopropane is much more reactive due to the bond angles in the ring, 109.5 degrees for each angle. The most reactive to least reactive of functional group. The most reactive of functional group is alkyne. The second is alkane. The third is aromatic hydrocarbon. The fourth is cycloalkane. And the last or least reactive of functional group is alkane. Higher boiling point and melting point for each type of functional group. The more substituent on the hydrocarbon, such as methyl, ethyl, propyl, the higher boiling point and melting point. The more carbon and hydrogen in the hydrocarbon, the higher boiling point and melting point. The example is N-pentane and 2,2-dimethylpentane. 2,2-dimethylpentane has a substituent and N-pentane doesn't have any substituent. Thus, 2,2-dimethylpentane has higher boiling and melting point. Next, we'll proceed to the questions for the hydrocarbon. In the first questions, we are going to draw a structure of the hydrocarbon for part A, 2-ethyl-3-methyl-octane. First, we are going to draw an octane, which consists of 8 carbon atoms. Then, as we can see, in this hydrocarbon has a substituent, which are ethyl and methyl. First, we are going to draw the 2-ethyl by counting from one side of the hydrocarbon, and we are going to draw it in the second carbon. Next, we are going to draw the methyl in the third carbon by counting from one side of the hydrocarbon as before. After that, we are going to add the hydrogen to fulfill the bond of carbon atoms. And for the information, each carbon atoms has only 4 bonds. And finally, this is the structure of 2-ethyl-3-methyl-octane. Next, we'll proceed to the B part, 2-pentene. First, we are going to draw 5 carbon atoms, since we are going to figure out the pentane structure. Next, we are going to count from one side of the hydrocarbon to draw out the double bond, which located in between the second and the third carbon. Next, we are going to add the hydrogen atoms to fulfill the bond of carbon atoms. And this is the result of the structure of 2-pentene. Next, we'll proceed to the C part, 2,5-dimethyl-3-heptane. First, we are going to draw 7 carbon atoms. Since we are going to draw the heptane structure, and then we are going to draw out the triple bond by counting from one side of the hydrocarbon, and we are going to draw it in between the third and the fourth carbon atoms. Next, we are going to draw out the substituents, which is 2,5-dimethyl, and the methyl will be drawn in the second and the fifth carbon. Next, we are going to add the hydrogen atoms to fulfill the bond of carbon atoms. And this is the structure of 2,5-dimethyl-3-heptane. Next, we'll proceed to the D part, 2-chloromethylbenzene. First, we are going to draw out the toluene, or we can call it as benzene. Then we are going to draw the methyl. And we are going to count it from the methyl until 2, where the chloro will be drawn. And this is the result of the structure 2-chloromethylbenzene. Next, we will proceed to the second questions, which we are going to name the structure of the hydrocarbon. For part A, first we are going to count which carbon atoms is the longest in this alkane. And as we can see, in this hydrocarbon, we can figure out that 7 carbon atoms is the longest structure. Thus, the parent name is called heptane, since all of them is single bond, which we know it as alkane. Next, we are going to figure out the substituents that are included in this hydrocarbon. And we can see that there's a 2 substituents in it, which are ethyl and methyl. And we are going to count it from the one side of the hydrocarbon, which is the nearest towards the substituent. Because right side is the nearest towards the substituents, thus we are going to count it from the right side. Count from right side, we can get that ethyl and methyl are located in the 3rd carbon. And for the information, naming the substituents must according to the alphabetically. Thus, this structure can be named as 3-ethyl-3-methylheptane. Next, we will proceed to the B part. And this hydrocarbon is an aromatic hydrocarbon group, which the parent name is benzene. And we can see that there's a substituent in it, which is methyl. Thus, this structure can be named as methylbenzene or toluene. Next, we are going to proceed to the C part, and we can see that in this hydrocarbon, there is a triple bond in it, which is an alkyne group. Then we are going to find the parent name by counting which carbon atoms is the longest in this hydrocarbon. And as we can see that the longest structure in this hydrocarbon is 4 carbon atoms, which is but. And we can simplify the parent name as butyne because in this hydrocarbon contains triple bond. And next we are going to figure out where is the triple bond located. And we are going to count it from the left side, and we can see that the triple bond is located between the 2nd and the 3rd carbon. Thus, this structure can be named as 2-butyne. Next, we will proceed to the D part. And this hydrocarbon is an aromatic hydrocarbon group, because it has a ring structure and all of them is single bond. And next, we are going to count how many carbon atoms are in this hydrocarbon. And as we can see that there's 5 carbon atoms in this hydrocarbon, which the parent name is pentane. And because this hydrocarbon is a cycloalkane group, thus this structure can be named as cyclopentane. Next, we'll proceed to the E part. And as we can see that this hydrocarbon is an aromatic hydrocarbon group, which the parent name is benzene. And next, we are going to figure out the substituents that are included in this hydrocarbon. And as we can see that there's methyl, chloro, bromo, and fluoro. And next, we are going to figure out where's the substituent located. And the methyl is located in the 1st carbon atom, the chloro is located in the 2nd carbon atoms, the bromo is located in the 3rd carbon atoms, and the fluoro is located in the 6th carbon atoms. Thus, this structure can be named as 2-chloro-3-bromo-6-fluoromethylbenzene or 2-chloro-3-bromo-6-fluorotoluene. And next, we'll proceed to the F part. And this hydrocarbon is an aromatic hydrocarbon group, which the parent name is benzene. And as you can see that this hydrocarbon contains substituent, which is called nitro, and we are going to figure out where is the nitro located. And the nitro is located in the 1st carbon atom, 3rd carbon atom, and the 5th carbon atoms. Thus, this structure can be named as 1,3,5,3-nitrobenzene. And that's all for the lesson today. See you tomorrow and goodbye.